Hey guys, so we're going to look at how to do series and parallel circuits. We're going to talk about series circuits first. So what I've done is draw a very simple series circuit. And this is how you draw circuits. These are resistors. I just draw little squigglies. This is a battery. The long side, your long side is your positive side. And the short little side is the negative side. And how we think about current is incorrect, which is hilarious. We actually think about it in terms of how Benjamin Franklin came up with it. So we think about current as positive charges going from the positive end to the negative end. It's not really what's happening. There's actually, what's going on is negative charges are going from the negative terminal to the positive terminal, but actually it doesn't matter because negative charges going one way are the same as positive charges going the other way. So we always think about positive charges going around to the negative end. That's called conventional current. So how do I solve a series circuit if I ask you to solve for things, right? Well, the first thing that you're going to do is you're going to find total resistance. Total resistance in a series circuit is very easy. We call that RT. To find total resistance, you just add up all of the resistors. So we're going to do 2 plus 1 plus 1. We have a 2 ohm, a 1 ohm, and another 1 ohm. So 2 plus 1 plus 1 is a total of 4 ohms. So that's our total resistance of this circuit. You're going to need VT, which is the terminal voltage of your battery. And that's known. It's 12. Easy. Now, what's our total current? To find total current, we use Ohm's law. I equals V over R. We take our VT of 12, divide by our R of 4, and that's 3 amps. That's our total current. That's a ton of current. Alright, so if you're asked to find total current, that's how you do that. Total resistance. You just add them all up. No problem. The hard part, and the only other thing we got to do is you have to be able to find what's called voltage drop. Voltage drop is how much voltage each resistor is going to take up or use in the circuit. And I do something here. I've done this for years. I consider voltage in a series circuit like pizza. So if we're in class, there's like 30 of us, right? And I'm going to order us pizza. I order us all, a couple pizzas, whatever it is, to cover everyone in the class, and pizzas show up. What happens? Well, you guys get on your phones and you start telling all your friends that, hey, we've got pizza down in Sharkey's room. And dang it, if people don't start showing up, all right? And what happens when people show up into the room to get this pizza? Well, the total amount of pizza for everybody gets smaller because more people are showing up. And that's how voltage works in a series circuit. The other issue is that football players tend to show up. And actually this has happened. And they're big guys. And they eat a lot of pizza. So I liken this to resistors that are big. If they're big, they're going to eat a lot of pizza. Just like our football players do. All right? And the more people you have in your circuit, just like the more people that come into the room, the less voltage there is for everybody. So in this circuit, the amount of voltage we have is 12 volts. So that's it. So how much voltage does this resistor use? I tend to draw this like this. What would the drop be from here to there? Okay, because if we draw a picture here right now, on this side, all this, if I take a voltmeter and hook it up to my circuit right here, this whole part is going to say 12 volts. So how much voltage does this guy use? Well, it's called voltage drop, and it's pretty easy. You just use Ohm's law. You're going to solve for V. So it's going to be V equals IR. This is R1, so the voltage used by R1 is V1. Now, how much current does R1 see? So if R1 was standing on the side of the road at a race, and all the runners are going to run this way, how many runners would this person see? Well, they're going to see them all. All the current's going to go this way and back into this side. So if our total current is 3 amps, then our total current that this guy sees is 3 amps. Each resistor is going to see the maximum amount of current. Okay. What's the resistance of R1? Well, it's 2. It's that. So 3 times 2 is 6. So the drop here is 6 volts. That's our drop. So this resistor uses 6 volts. That's how much pizza that person eats. So over here, on this side, what would our voltmeter read? Well, 12 minus 6 is 6 volts. So now we only have 6 volts left. Okay, well, what's the voltage drop for this person? Well, they see the same current. They see everybody. So they see 3 amps. How much resistance is this one? Well, it's just 1. So they're going to use 3 volts. That's how much pizza they're going to eat. They're not quite as hungry or quite as big. All right? So this person is going to use 3 volts. Well, we had 12 volts. This guy ate 6, so now we have 6 left. This person eats 3, so if we put our voltmeter over here, this is going to say there's only 3 volts left. Now, how much voltage does this person use? Well, the same as this one. It's going to be 3 volts. Pizza always gets eaten. If you put pizza somewhere, it gets eaten. And that's what happens here. So on the back end of our circuit, if you put a little meter there, the meter is going to read 0 volts. It's amazing. That's how series circuits work. Alright guys, here's a parallel circuit. It's very similar to the one I built for that last video. So, I've got 3 resistors. They're all in parallel. I made VT24, kind of big. So, here's what you do. First thing we got to do is we have to find total resistance. This is a little different, because what we got to do is we still add them up, right? So RT is going to be R1 plus R2 plus R3. But remember what we talked about, how parallel circuits are a little weird. And if you keep adding things, everything stays nice and bright. So what actually happens is the equation looks like this. You put a 1 over them. So, what I actually do here, it's going to be 1 over 10 plus 1 over 20 plus 1 over 30. I'll go ahead and do that on my calculator. I get some decimal. I get 0.183. And the reason I don't get something that looks very friendly is because what I just got was 1 over RT. I don't want that. I want RT. I want total. So I'm going to take the reciprocal, and that gives me RT 5.45 ohms. And I find the reciprocal. Okay? First thing. That's called equivalent resistance, or total. And it's a little wacky. And what that means is if I keep adding things, I'm adding fractions, so my total number actually gets smaller, which is why things are wired this way, because we can add as many lights as we want and everything stays nice and bright. Okay. The next thing to do is we can find our total current by using Ohm's law. So we take our total voltage, which is 24 volts, and divide by our total resistance, which is 5.45. So 24 divided by that. I got 4.4 amps, around 4 amps. of current, which is a lot. So there you go. So these are a little more work. Now, the only other thing you're going to be asked to do, well, you're going to be asked to do a couple different things, but the big thing that you would be asked to do is to find the current in each branch. So these are called branches. What happens here is current comes out of here, and it can go there, call that I1, it can go here, call that I2, or it can go up here, call that I3. So your current actually branches off into 3 branches. And then what happens is that all these little branches meet back up on the backside. So you get 4.4 amps coming out, and you get 4.4 amps coming back in. So the question is, how much current is in each branch? And to do that, it's pretty easy. You just use Ohm's law. For each branch, total voltage is the same. It's 24 volts. So for this first branch, I would do 24 divided by this R, which is 10. For this branch, I would do 24 divided by 20. For this branch, 24 divided by 30. And that would give me all of my little currents. I have 3 currents. So I get 2.4 here. I get, 1.2 for that second. And I get 0.8 up here. And what's cool is if you add all these up, 2.4 plus 1.2 is 3.6. All those added up, will be equal to our total current, 4.4 amps. So that's pretty cool. I guess the question is, why does each branch get the 24 volts? Why does that happen? And I hope this makes sense. Zoom in. If you look at this, here's the positive plate of your battery. And notice what it's connected to. The positive plate is connected to everything over here. Okay? Your negative plate, this is our little negative plate here, is connected to all this stuff. So what this actually is it's really like it's one big giant battery, really, because this whole side, all this stuff is positive. And it's all connected. And this whole side is all negative, and it's all connected. So if you keep adding things, they're still physically connected to this battery, which means you're always going to have your 24 volts. Pretty cool. So this is how parallel circuits work, and there you go.